Hi, everybody. Can you hear me? Online? Okay. All right. So welcome to IGCSEflix. Okay. So today we're going to do chemistry. Okay. Everybody has their notes? Yeah. Okay. Today I'm only going to focus on 3 things. If we have extra time, we have extra time. If we have no extra time, then we won't do it. Okay. But I want to focus on these first 3 things. The first 3 things I want to focus on is stoichiometry and calculation. Number 2 is organic chemistry. And the third thing we want to focus on is paper 6. Okay? Come. Okay, so if everybody looks at the first page, okay. So I'm only going to focus on 3 parts today, okay? All right, because if I teach you all too much, I think it's like, too much information. So we're going to do organic chemistry, we're going to do stoichiometry, and we're going to do paper 6. Okay, if we have extra time, we will do extra stuff. All right? Again, no need to worry about copying everything. Marking scheme will be given. Okay, can see or not? Is the angle okay? If you can't see over there, okay? All right, now, do all these formulas look familiar? Amount of moles equals to MV over 1000. Amount of moles equals to mass over molar mass. Amount of moles equals to volume over molar volume. Do they all look familiar? Yeah, right. Okay, so what is it? Which one is for what? Okay, so amount of moles MV over 1000 is only for an aqueous solution. How do you know something is an aqueous solution? They will tell you aqueous solution of acid, aqueous solution of alkali, aqueous solution of salt, and then the aqueous solution will have a unit for the concentration, which is mole per decimeter cube. Every time you see this unit, this is the M for MV over 1000. I know some of your schools, you learn it as CV. Same concept. It's concentration times volume. Okay? So all you have to remember is the V in MV over 1000 is usually given in centimeter cube. That's why we divide 1000 to get it back to decimeter cube, right? Okay? Later we'll try some calculations. Now, amount of moles is mass over molar mass. Is anything that they give you the mass. As long as they give you the mass, it's mass over molar mass. Okay? And then, do you need to memorize molar mass? No. They will give you a periodic table. Remember to look at the periodic table. Okay? And finally, amount of moles is volume over molar volume. Molar volume is 24 decimeter cube or 24,000 centimeter cube. Depends what unit they give you lah. Alright? And this is only applicable to gas. Now, sometimes when you see the question that has a volume of, then you get confused. Which volume are they talking about? Now, if it's a gas, it's this formula. If it's an aqueous solution, it's this formula. Okay? Can? So the normal calculations of stoichiometry are, I ask you to find the amount of moles of this, you find the concentration of something else, or you find the volume of something else, a simple question. Or other kinds of question is percentage yield, empirical formula. Okay, percentage yield and empirical formula. We're going to do both of those together today. Okay, now, one other thing that is not really part of stoichiometry, but it is part of calculations and it's usually the same question, is the relative mass. Okay, so we know that in the periodic table, some elements have the relative mass of a decimal point, 0.5. Okay, why does it have a 0.5? Because it is the average of all the naturally existing isotopes as compared to carbon-12. Correct or not? Okay, so the relative atomic mass, when they give you something like this, basically what you do is you take the first one, multiply the percentage. Okay, that means 63. Multiply the percentage 70. You add it together with the second one. In this case is 65. Multiply by 30. And you divide 100. You're just calculating the percentage. Okay. And then this kind of question, right? In chemistry as well as bio, they like to ask you this kind of thing. 1 decimal point, nearest whole number, 3 significant figures or 2 significant figures. So it's actually not difficult math. It's very simple math. All you need to do is read carefully because it's only a 2-mark question. You do your calculation correct, it's 1 mark. You forget to write down the 1 decimal point, or you forget to write down, nearest whole number or whatever, then you lose marks. Okay? So it's basically just reading it carefully. Okay, now, 63.6. Easy, right? Okay. I hope you have a calculator. If not, you can use your phone calculator. I don't mind. Okay, question 2 is the other way around. Question 2 is the other way around. Okay. So, basically, boron 10, okay, the percentage of boron 10 plus the percentage of boron 11, if I add it together, has to be 100. Correct? It has to be 100, right? So this is a terbalik question. I hope you get this, but this also can ask. It's the same thing. Okay? So basically, let's say we don't know what is the percentage of percentage of boron 10. So boron 10, the percentage is X. So we take 10 multiply X. We don't know what's the percentage. Same as this. This one we know the percentage, 70%. This one we don't know. Okay? We add together with, now, here's the tricky part. If X is the percentage of 10, what is the percentage of 11? 90 lah. If this one is 10%, if this one is 10%, okay, we have B10 and B11. Okay, if this is 10%, this one will be 90. Correct or not? If this is 20%, this one would be 80. If this is 30%, this one would be 70. So basically, whatever I do, I add together, it must equal to 100. Okay, so 11 A okay, 11 multiply 100 minus X. We don't know what it is. Okay, we don't know what it is. It could be 10%, 20%, 30%. All I know that if here is 10%, here will be 90, 100 minus 10. If here is 80%, here will be 100 minus 80, 20%. Do you understand? It's algebra. Okay, so this value, you do the same math. Divide by 100 equals to how much? Is it given in the question? Yeah, it's given in the question. Equals to 10.8. Okay? It's just math. Do you know what I'm doing? It's just algebra, okay? So X equals to 20%. Do you understand? The most important part of this is the 100 minus X. Okay? That's the most important part of this. If you didn't catch it, don't worry. the YouTube has a copy of it. You can go back and watch it again. Okay? Can? Do you understand the concept? Okay, so I know some of you are still copying it. I won't rush you all. Okay, let's try some calculation questions. If you are done, let's do objective. Yay, objective is so easy, teacher. Let's do some objective to warm up. Okay, can? All right, so for those of you who just came in, I just want to let you know, today I'm going to focus on 3 topics only. First topic is stoichiometry, calculations. Second topic is organic chemistry. That means after we finish all this calculation, we do organic chemistry. And the third one is we're going to do paper 6. Okay? Can? So you're going to focus on these 3. Okay, so if you're done with this, what I want you to do is turn to page 2 and try and do question 3, 4, 5. Okay? I know you all just ate lunch. Okay? So we are like warming up your brain. Try and do question 3, 4, 5. Can see in front? Okay, this is the answer for question 2. We're doing question 3, 4, 5 now, okay? If you're done with 3, 4, and 5, come here and tell me your answer. Okay? If you're done with 3, 4, and 5, you come here and tell me your answer. Then I'll give you something. Alright? Do you get the paper? Okay. This is question 2. We're doing 3, 4, 5 now. Okay? I know you all are like, just came back from lunchtime, warming up your brain. If you're done, come here. Don't be shy, okay? Come and tell me your answer. All right? Has the answer? Come on. You must do all 3, okay? Question 3, question 4, question 5. On page 2. Okay, this is page 2. On page 2. Okay? Come. Okay. Two out of 3. Okay. Okay, you start first. If the second person also gets 2 out of 3, then both of you get a present, okay? Okay, come on. 2 out of 3. Not bad, not bad. Come on. Who else? Sorry, people online, I can't give you a gift. Okay, I can't send it. Come on now. You come here. Okay. Tell me your answer. If you got the answer, come. Give me a paper. Let me see. Oh my goodness, you got your answer, is correct. I'm looking at the wrong question. Wait. Okay, she got 3 out of 3, you got 2 out of 3. Okay, you get the first prize. Come. Okay, you get the second one as well. Come. All right, we'll discuss. Okay, wait, I give her first. I looked wrongly at the wrong question. Whoever, oh, sorry, just a little bit. Side first. Okay, good job. Okay, star. Okay, come. Sorry, please. Okay, good job. Get a star. Okay. All right, good. Okay, come, let's discuss together. Teacher, my fried chicken is still in my brain. You make me do work. Okay, never mind. All right. Now, how many questions do you have in objective in your paper 2? You have 40 questions. Okay, probably 2 or 3 are calculations. If you are a person who is not good at calculations, you're really not good, don't spend half an hour on one question because you only got 45 minutes. So what you should do is do everything first, come back to it later. Do everything first. Okay? Can? Alright. So what happens is, I really hope that your exam question is very easy. Okay? Alright, come, let's do it now. C, H, and O. Okay. Always remember to read carefully. Teacher, where got O? They say oxygen ma. Alright, so 26.7 is carbon. 2.2 is hydrogen. So oxygen is 100% minus 26.7 minus 2.2. So you get how much left? 71.1. Correct. Okay, so this is the percentage. Do you understand? Okay, so then actually the answer also will give you a clue lah. Got CHO, CHO2. All right, so it will give you a clue. But if you're reading it through fast, you will also, how come not 100? So then what you do, divide by the molar mass. Carbon is 12, hydrogen is 1, oxygen is 16. So you will get 2.22, 2.2, 4.44. So the ratio is 1, 1, 2. Answer is D. Do you understand? Can? Okay. All right. The volume of methane is 0.5. If this is 0.5, it reacts with 0.5. So notice here is gas. If it's gas, we can just do this ratio. Okay? So if this one is 0.5, the ratio is 1 to 1 to 1 to 3. The moles is 0.5. 1 is also 0.5. This one is 3. So 0.5 times 3 is 1.5. But they are not asking you the moles. They are asking you the volume. Volume. How do you calculate volume? Moles multiply molar volume. Moles 0.5 times molar volume 24. You get 12. So 12. Get it? Okay? And then the second one is 1.5 multiply 24. You get how much? 36. So you got D, right? Correct, right? Yeah. I looked at the wrong answer. Okay, can? Do you understand? So remember, this is gas. So the formula for gas is 1 mole gas is 24 decimeter cube. Okay? All right. Don't worry if you can't copy. Remember, this is not copying session. Don't worry. You go back. Answers are online. The YouTube also can watch and pause. Okay? Can open big and see what you're gonna see. Okay, so don't worry about that. Okay. The gas hydrogen has the molecular formula of N2H4. Okay, N2H4. Hydrogen burns in air to form nitrogen and steam. Okay, so which one is correct? 1 mole of hydrogen, okay, gives 72 decimeter cube of gaseous product. So if this is 1 mole, then the product here will also be 1 mole, and here will be 2 mole. Teacher, that one water. I know that one water, but they give you gas. So gas can just combine together, the gas and gas. So gas you can add together. So 1 plus 2 is how much? 3. 3 mole of gas. So 3 mole of gas, how much? 1 mole of gas, 24. 3 mole of gas is 72. Okay, so the first one, betul. Correct. Okay? The empirical formula, N2H4, smallest ratio, is it NH2? Yes. Okay? Okay? Total number of atoms in 1 mole. Okay, atoms are, so you look at this, here, okay, N2H4, 1 molecule got 4 atoms. What's wrong with me? 6 atoms. So the total number of atoms in 1 mole is 6 atoms multiplied Avogadro's constant. Correct. Okay. The volume of 1 mole is just 24. It has nothing to do with 6. The volume of 1 mole is actually just 24. So number 4 is wrong. So the answer is A, 1, 2, 3. Okay? Okay? Got it? Yeah. So, I also don't like this kind of questions. You know why? Have to read slowly, and they like to trick you with that little bit of word change. Okay? Because it is actually seeing how well you understand something. Okay, I also don't like this question, but that's how questions are asked lah. Okay, can? Now, sorry, I just went into it. I forgot to tell you something. Those of you, I'm not sure how many of, maybe not all of you were here for bio, but I'm going to tell you the same thing. Your 2 best friends for your exam is your syllabus content and your, I think most of you here for bio though. Okay, syllabus content and also your past year paper. Okay, past year paper for 2026, May, June and March already out. Go and do. Go and do. All the papers are online. Some people ask me, teacher, where to buy? No need to buy. Everything is online. Okay, and it's free. So nice, right? Okay. Now, what I suggest you to do is do the whole series. Do the whole series and then check your answer. And if that particular paper you got bad results, read, study again, and then go and do the paper again. Okay? But I'm doing the same thing. Good lah. I'm repeating the same question. Good lah. Past year paper is also repeating the same question, right? Okay? If you go and do the old past year, no, okay, not that old lah. Maybe like 2016, 2012, 2020, 2018, you will notice that, how come the question all same? Questions are very, very repetitive. Okay, very, very repetitive. The same questions asked because it's just the same topic. How many ways can they ask you? Right or not? So, do past year paper. You will notice they're all the same. Okay? All right. This is the hardest MCQ question ever for calculation. If you can do this, 100% you can do anything. Okay, this is the only question that I've ever seen that is really like, OMG, so difficult to calculate. Okay, can? Okay, now, I will not give you so much time because I will give you 5 minutes. 5 minutes, you do question 6 and question 7. Okay, then we will go to structured questions. Okay, can? And if you can complete this, then we will do organic chem. All right, question 6 is really, really the hardest. So maybe you want to start with question 7. Okay, so The concept of percent. Okay, maybe I teach you question 7 first. Okay. Sorry. I teach you question 7 first. No, you all feel very stressed. Okay. The concept of percentage yield. Okay. Teacher, where got this in my syllabus? God, it's just that not very often asked. Okay. Percentage yield, they still ask you. Percentage yield means what? I have all my ingredients. I have all my ingredients to make 100 cookies. But after I make the dough, make everything, I only got 90 cookies. Why? Some fall on the floor, some fall into my mouth. I only got 90 cookies out of 100. I am supposed to get, but because of the amount of flour, sugar, chocolate chip, everything I bought, I am supposed to get 100 cookies. So that 100 cookies is my, in theory, it's called theoretical yield. Okay, sometimes they like to use this kind of big words and then you wonder what I'm talking about. So in theory, the theoretical yield, I'm supposed to get 100, but I actually in my kitchen I only got 90. So this is the actual amount. So what is my percentage yield? 90% lah. Only 90%. So in this question, in this kind of question, when they ask you percentage yield, you're supposed to find out. That's why a lot of students get very confused. What is the percentage yield? They give me copper oxide. There, teacher, they give me copper oxide. Why I need to find copper oxide? No, this is the copper oxide that they managed to get actually. You need to calculate the theory. How do you calculate theory? Like that, the long way lah. First, they give you 31 gram of copper carbonate. Find the amount of moles of copper carbonate, and then use the ratio, find the amount of moles of copper oxide, and then multiply the molar mass of copper oxide. Okay, do that. Okay, so I give you the steps. Step 1, find the amount of moles of copper carbonate, mass over molar mass. Step 2, find the amount of moles of copper oxide using the ratio method. And step 3, find the theoretical mass of CuO. That means in theory, how much I'm supposed to get. And then calculate your percentage yield. Okay? That means I only got 17.5. How much am I supposed to get? You're supposed to calculate here. Times 100. Okay, you do that first. Try that first. Copper is 64, oxygen. Copper is 64, oxygen is 16, carbon is 12. Okay? Okay, molar mass of copper 2 carbonate 124. You managed to get that? Yeah? Copper is 64, oxygen 16, carbon 12. So CuCO3 is 124. Okay? 31 over CuCO3 is 0.25 mole. Did you get that? All right. So using the ratio, using the mole ratio method, the ratio of this to this is 1 to 1. So if this one is 0.25, this one also 0.25. Correct? Okay. Now, CuO 64 plus 16 is 80. So in theory, what am I supposed to get? 0.25 multiply 80 equals to 20 gram. So in theory, I'm supposed to get 20 gram. Did you get that? Yes, in theory, I'm supposed to get 20 gram. But did I get 20 gram? No, I only got 17.5. So you find the yield, 87.5. Teacher, count so much for one question. Yeah, but actually, if you know, it's very fast. So that's why I said, if you're not good at counting, leave it to the end. Okay, I give you all 2 minutes to digest this information. If you don't understand, ask me. What is it? Ask lah. Okay? If you don't know, ask. Not sure, ask. Okay? What is it? No. Okay. If you're done, if you're digesting, digest. If you're digested it already, try question 6. Question 6, I'll just give you 5 minutes to try. Okay, question 6 is the hardest, not hardest in the world, but it's the hardest question that I've ever seen for objective. Okay? If you have done the question before, then not fair. If you have never done the question before and you manage to count the answer, then you tell me, okay? I got no more present for you, but I'll give you a 2 thumbs up. Okay? I give you 1,000,000 points for IG. Question 6. Okay, you're done with this question? Can? Okay, question 6. If you have never done it before and you found the answer, you tell me. If you have done it before, then don't tell me lah. Okay, they're not fair, okay? To be fair, this question is not May June series, it's not October November series, it's the March series. So March series memang susah sikit one. It's the India paper. India paper means you can only have it in India in March. Alright, so their papers are slightly harder. So if you can do that paper, you can do anything. Alright. So go and download the M series, S series, and W series lah. I mean, this year W belum lah. That's called soalan bocor. So the S26 and M26 came out already. Okay. Anybody? What did you get? What did you get for question? Try again. Close. I know why you got that answer. First, calculate the percentage yield. Percentage yield can use volume also. Percentage yield can also use volume. Okay? Percentage yield can also use volume. Okay? Okay? Okay, when one person tells me the correct answer, then I will stop. Then I will teach. Yes. Yes, it is A. Okay. You got A? Yeah, okay, very good. Okay, now. Oh dear, I just ate fried chicken. My brain is still fried. Okay, so now, first of all, sodium hydrogen carbonate is this one. MR is 84. Okay? This one is 84. Then this one is 106. Okay, that's the molar mass. 2 in an experiment, 2.1 gram of sodium hydrogen is heated. But, okay, look at the thing, but not all decomposed. That means not all reacted. So, let's see in theory, how much am I supposed to get? Okay, in theory. So, you guys are not very good at whispering. I can hear you from here. Okay, 2.1 over 84 for sodium carbonate. Okay, I'll write it at the side. Okay, so moles of sodium hydrogen carbonate that is given is 2.1 over 84. So I am given 0.025 mole. Okay, I am given 0.025 mole. Okay, now, but not all decompose. Okay, if this one 0.025, how much of this am I supposed to get? Same, double, or half? Half. Because the ratio is, you can see from here, the ratio is 2 to 1 to 1 to 1, right? So, I am supposed to get 0.0125 and I'm supposed to get 0.0125. Okay? Now, the total of volume of carbon dioxide I actually got, this is actual, is only 0.21. Okay, first we find out how much carbon dioxide am I supposed to get in theory. In theory, carbon dioxide I'm supposed to get is volume multiply molar volume. So I am supposed to get 0.3 decimeter cube. But did I get 0.3? No, I only got 0.21. So my percentage yield is, I'm supposed to get 0.3 carbon dioxide, but I only got 0.21. So this is 70%. So this is wrong. Get it? Can see or not? Okay. Do you understand how I got 70%? Okay. Okay. If this one is 70%, this one is 70% or 100%? 70%. Get it? Okay. So, there's a few ways you can do it. Okay. There's a few ways you can do it. This one is 0.025, right? And this one is 0.0125. So they ask me, is it this or this? So I take 0.0125 multiply 106. I get 1.33 gram, which is the wrong answer. Why? Because this one is at 100%. But I only got how many percent? 70%. So it's A. It's only 70%. This one is theory. If I get 100% is 1.33. If I get 70% only is 0.93. Understand or not? Can see or not? Can see, okay? It's okay, this one is the hardest question. After this is easier already, okay? Which part you don't understand? Don't say everything. Which part you don't understand? Okay? Never mind. You go back and watch this again. This is the hardest one. You really read the hardest question, okay? Alright. Okay, can I go on? Okay, we do something easier, okay? Okay, we do something easier, okay? Now, this one definitely you know. Okay, look at page 5. This question. Question 9. Question 9. Okay? Question 9. Page 5, question 9. Okay, this one guarantee you can do. Okay? Guarantee you can do. One mole of gas is 24. You don't need periodic table for this. Concentration is molarity. Same. M in mv over 1000. Okay? So, remember just now I said, if you get, okay, your final answer is 1.2. Did you get 1.2? Okay, good. So, this one, whenever you see this kind of thing, 25, 2, it's always mv over 1000. Okay, every time you see this unit, it's always the m in mv over 1000. Okay, so m is molarity, 2, v is volume 25 over 1000. Okay, so you get 0.05. Okay? So the ratio is what? The ratio is 1 to 1 to 1 to 1. So it's the same. Right? Okay, hydrogen is the same. So how do you change mole to volume multiply 24? You get 1.2. Okay, what mistakes do students make? They don't see the decimeter cube. They don't see the decimeter cube. So sometimes they say decimeter cube, sometimes they say centimeter cube. Okay? Okay, we're going to do one last question and then we're going to do organic chem. Okay? And then you're going to think about which one is worse. Whenever I teach my students, then they will say, oh, teacher, moles. They love chemistry until they learn moles. And then they're like, moles. And then they learn electrolysis. Then they're like, oh, I miss moles. Electrolysis is so nice. It's so difficult. And after that, they finish electrolysis. And then they go to year 11. Then they learn organic chemistry. Remember the days we thought electrochemistry was hard? Okay. So, I don't know. I don't know what's your concept. Okay, some people might find it the other way around. Okay. 10. Okay. All right. Okay, I won't do this question. This one is an older question. The marking scheme is there. I want to do this question. This one is a more recent one. Okay. It's similar. Very, very similar. Very, very similar. Okay. You only need to use one formula, which is the amount of moles is mv over 1000. Only one formula. Okay. So open your eyes big and look properly. This one, 0.05 of calcium hydroxide. Okay. And this one is for nitric acid. Okay. So open your eyes carefully. Yeah. Okay. We do it 5 minutes and then we're going to do organic chem. Okay. Can? One. This morning you had what? Math? And oh, my fault. I shouldn't have started with maths. Because morning already at maths already. Okay, try. The first 3 parts should be easy. The first 3 parts should be easy. The last part you don't know is okay. I'll teach you in a while. If you get the final answer, let me know, okay? Okay, anybody got an answer? No, not yet, not yet. Okay. Hydrogen is 1. Okay, you might need this. Hydrogen is 1. Nitrogen is 14. Oxygen is 16. Is there supposed to be 1 screen or 2 screens? Also, I was wondering, do I have to answer any questions? Because I cannot see any questions. Oh, so if any questions, you will tell me lah. Oh, okay, because so far nothing, right? So far nothing lah. Okay, okay. Okay. Anybody? Okay. Can? What did you get? Okay, okay. Anyone got answer? The last one. This one. Okay, okay. The second last one? What? How much? Okay, correct. This one is 0.024. Okay, so how you do is, okay, I write here first so that if you got it correct, you can rejoice first. Okay. So, first you calculate MV over 1000. Calcium hydroxide, M is 0.015. V is 20 over 1000. So you get 0.0003. You want to write standard form also can. 3 times 10 to the power of -4 can. Okay. Then from here to here, ratio is 1 to 2. So multiply or divide? Multiply 2. So 0.0006. Correct? Okay. So you come back to the same formula. Amount of moles is M. I'm looking for M. V is how much? V is 25 over 1000. So my M equals to 0.024. Okay? You're just switching it around only. You're switching the same formula around. Okay? Can? Alright. This is in the unit of mole per decimeter cube. When you want to switch to gram per decimeter cube, you just multiply molar mass. Okay? Because it's mole to gram. So you multiply molar mass. If the question give you the other way around, divide molar mass. So that's why I gave you hydrogen is 1, nitrogen is 14, oxygen is 16. So HNO3 will give you 63. So you just multiply 63, you will get 1.51. Okay, so whenever they ask you to change from mole per decimeter cube to gram per decimeter cube, you multiply molar mass. Okay? Okay. Sudah. Okay. Organic chemistry, yay! Okay, before I move on, anybody has problem with moles? No, okay. Which one? Sorry. Any questions? Okay. Going once. Going twice. Okay? Okay. Everyone look at this page, huh? This one. The one with the big chart. Okay, this one I'll suggest you to do. Go buy lots of mahjong paper. Tell the shopkeeper, don't worry, I'm not playing mahjong. I'm sitting for IG exam. Okay? Then take all of these, draw big and stick on your wall. Okay? Draw all of these flow charts, all the important information, all the diagrams, and stick on your wall. Okay? Good? Got new poster and wallpaper. Okay. Ready, yeah? Okay. Okay, assistance required. Hold on. How do I turn it? Yeah. Or then it will.
Yeah, but it won't follow.
It won't follow, ah?
Yeah.
Oh dear. I should have thought of that. Sorry. How do I rotate it? Because they are going to do it. They are going to look at it this way. Can I rotate the whole document? Yeah. Just the whole document rotate first and then later I rotate back. It's okay. Doesn't matter. Yes, thank you. All right. Okay. Okay, so let's see. Okay, this is organic chemistry. Okay, everything that you need to know we put in one table, put in one flowchart. Okay, everybody has this. Is on your page. You guys don't know what page is this? 6. Page 6. Okay, so you go home, teacher mahjong paper too big. You buy art block lah, drawing block. Then you draw. Okay, now we start with the middle. Why do we start with the middle? Because ethene is the most reactive. Why is ethene most reactive? Because ethene has carbon to carbon double bond. It is unsaturated. Unsaturated is always reactive. Okay, what's the general formula? CnH2n. Correct or not? Okay, let's draw ethene. C double bond, hydrogen, 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 hydrogen. Okay, now, what can an alkene do? So many things. An alkene is very, very reactive because it is unsaturated. Because it is unsaturated, because it has saturated, it has carbon to carbon double bonds. It's a very reactive chemical. So every year they will ask you the same question: how to differentiate alkene from alkane? And what is the most important way to do it? This one, you add bromine. Okay, what is the smiley face? Color change. Now, if you look at older papers, they will say bromine is brown. If you look at the younger papers, they will say bromine is orange. Did bromine change color? No, it's because you want to compare. Iodine also brown, orange is also brown. Orange is also brown. Iodine is also brown, bromine also brown. Correct or not? How am I supposed to know whether you're talking about iodine or bromine? So generally, iodine we say brown, orange, bromine we say orange because it's a lighter solution. Understand? So orange to colorless. Why? Because when you add the bromine, it will react with alkene and then it will become. So how does it react? So you imagine your alkene, the double bond here, okay? The double bond here is basically somebody with the arms folded. So because the arms are folded, don't you think they can open up their arms and hold things? Yes. But an alkane is something that's already holding. So alkane can react with you or not? Cannot. Alkane already hands full. Okay? So what happens here is the alkene will open up the double bond. And then it will become single bond, bromine, bromine. Why is it called 1,2-dibromo? Because the bromine is on the first and second carbon. If something like this were to exist, okay, sorry. I draw nicer. if something like this happens, what do you call this? 1,1,1-dibromoethane. This would be called 1,1-dibromoethane. Okay, very important question. Can 1,1-dibromoethane be formed from ethene? I got ethene. I add bromine water. Become 1,2. Do you know why is it 1,2? Because on the first carbon, second carbon, so 1,2. Okay? This one is 1,1 because it's both on the first carbon. Can I make 1,1-dibromoethane from alkene, from ethene? Can or cannot? Yes, no? What do you think? Came up before in objective question. That means they give you a series of molecules and they ask you which one cannot be made from, what kind of reaction is this? Adding bromine is called what kind of reaction? Addition. Why is it called addition? Because only one product. Very good. So this is called addition. Addition of bromine. When I add bromine to alkene, which one cannot be made? This one cannot be made. This one can only be made by substitution. This one can only be made by substitution. Why? So I'm telling you cannot lah, but why? The double bond, okay, you must understand the empty space is here and here. So you can only put things that if the empty space in this hall is only this chair and this chair, two people come in, where are they going to sit? This chair and this chair. Where got people so stupid going to sit on you? No, right? I mean, like that, then they need to go somewhere else. Okay? So, if people come in, the whole hall is full, there's only 2 empty chairs. Of course, they're going to sit on the 2 empty chairs. Right or not? So, what happens here is, the alkene has only empty spaces in the first and the second carbon. Whatever you add into the molecule must go into the first and second carbon. So, this one cannot be made by addition. It can only be made by what? What did you say just now? Substitution. This one can only be made by substitution. Okay? So, it came up before objective question. Why make this, not that? Can you understand? Okay, Alright. Let's try the next one. Okay. Can you please write down, okay, very important. Got any special conditions? No, don't have. Bromine, just add only. No need to do anything, just add. Okay? This one needs special condition. This one needs special condition. This one needs special condition. Let's try. Can you go this way and write down what is the special condition to change ethene to ethane and draw the product and write the general formula of ethane? Go, do. Can. So addition of hydrogen. The general formula is CnH2n plus 2. This is alkane. So remember, this one is alkane, this one is alkene. Okay, I forgot to write the... So if they ask you, okay, if they ask you what is the homologous series, alkane, alkene. If they ask you what is the general formula, CnH2n plus 2, CnH2n. That's general formula. If they ask you the displayed formula, Displayed formula is not the same as structural formula. Structural formula is the one you write CH3, CH2, CH2, CH3, OH like that. That is structural formula. Okay. When you add hydrogen, what are your conditions? Hydrogen. Catalyst, nickel. Temperature 200 degrees Celsius. Need to memorize, yeah. Okay. What about going down this way? Try this one. It's also an addition reaction. Yes, it's steam. Addition of steam. Teacher, why you write water? Because it's at how much temperature? Who can remember? 300 degrees Celsius. Okay. Catalyst. This one need temperature. Okay, this one is another very common question. Got a lot of things to ask. Temperature, pressure, catalyst. 60 atmosphere. Okay, 60 atmosphere. 60 atmosphere is the pressure. The catalyst is phosphoric acid, but you don't need to remember phosphoric. You just remember acid. Just remember acidic conditions. Okay? 300 degrees Celsius, 60 atmosphere. So what happens is ethanol is alcohol. General formula is CnH, 2n plus 1 OH. Okay, this one a lot of students draw wrong. You see, this part, right? It is O-H, like that. I mean, your O-dash, your dash can be up or down, doesn't matter. But it's O and then 2 dashes. One for O, one for H. Okay? Can you see? Okay, now, there are 2 ways to make alcohol. Okay? There are 2 ways to make alcohol. One way is hydration. Is this way good or bad? Both, okay, this way is using alkene. So this is called addition of steam at 300 degrees Celsius, 60 atmosphere. What percentage of ethanol will I get? What percentage? 100%. I will get 100% ethanol. Is ethanol important? Yes. Why, teacher? Oh, I know, teacher, make beer. This one, if you make beer, what will happen? You will die. This is 100%. 100% ethanol cannot drink. Okay? What is it used for? It's used for a fuel. It is used to make perfume. It is used to make a solvent for all sorts of medicine, disinfectant. So it's a very, very important chemical. Okay, there is another way of making it, and the exam, they always like to ask you, compare which way is better. So how do they ask you? They will say the advantage and disadvantage of using this way, and what's the other way? Of course the other arrow going in Okay, how to make ethanol from glucose? What is it called? Here's the funny part. You take bio, it's called anaerobic respiration. You take chemistry, it's called fermentation. Can I interchange? Cannot. Fermentation of glucose. Okay, fermentation of glucose. This one is the same equation as your anaerobic respiration for C2H5OH plus CO2. 2, 2. Okay, who do I use to help me do this? Yeast. What's the condition? No oxygen, about 15 to 25 degrees Celsius. And then no oxygen. You no need to write anaerobic, no need to so changgeh for chemistry. Okay? So it's C2H5OH. Oh my goodness. So this is ethanol. Okay, where do I get the glucose from? Do you remember learning about this? This is, you know, when people grow sugar cane, okay? How do they get sugar out of sugar cane? I kid you not. When it's called sugarcane water, sugarcane juice, right? So I told my student about sugarcane juice. Do you know, he told me I was lying and there is no such thing as sugarcane juice. You know that big sugarcane, the cane, and then they put it in the machine and then come out the sugarcane juice? He said there's no such thing. I'm lying to him. He didn't believe that sugarcane juice came out from the sugarcane. Then I said, why did they put the cane there? He said, for decoration. Okay, so all of you are normal, right? You've seen this before, right? In Pasar Malam or wherever, you take the sugar cane, you para, come out all the sugar cane juice. In factories, that sugar cane juice is used to make sugar for eating. What do they do with the leftover? The leftover is called pulp. The leftover is called pulp. Now, this pulp can eat or cannot eat? Cannot. How to eat? It's tasteless. Even the panda bear don't want to eat. Okay, and pandas eat bamboo. They won't eat the pulp. So we take this pulp, we break it down, and we let the yeast eat it. And the yeast will change it to glucose. The yeast will change it to ethanol. Okay, is this good or bad? This makes ethanol that can be used as a fuel. Not for drinking also. This makes ethanol that can be used as a fuel. It is renewable. The advantage is always this is renewable. Because you run out of sugar cane, what can you do? Grow some more sugar cane. Teacher, why is ethene non-renewable? Ethene comes from petroleum. Petroleum is non-renewable, right? So this comes from glucose. It comes from sugar cane or whatever left over from the agriculture industry, okay? Or the sakibaki. For example, I take the paddy, I take out the rice, the leftover husk can eat or not? Cannot. I use it to make this. I feed it to the yeast. Get it or not? Okay? Now, renewable. It uses high temperature or low temperature? Low temperature. 25 compared to 300. 300, I need to a lot of energy. But the problem is the yield is high or low? Very low. 5%, 10%, your yeast all die already. Cannot. Okay? Also, it is fast or slow? Slow. So this one is slow. This one is fast. This one is fast. This is slow. This is high yield, 100%. This one is 100%. Okay? 100% yield. This one is low yield. So this is a comparison they will ask you to do. So there are two ways of making ethanol. Remember that, okay? All right, finally, let's go this way. What is this? Ethanol to ethanoic acid. So ethanoic acid is carboxylic acid. General formula CnH2n plus 1 COOH. Correct? How many ways to make ethanol? Also 2 ways. Ethanoic acid, also 2 ways. What are the 2 ways? The first way is acidified potassium manganate 7. Okay, this is your best friend. Okay, KMNO4, they will ask you what is the condition? Acidified. They will ask you the name. What is the name? Potassium manganate 7. Every year they come out the same question. Bromine and potassium manganate 7. Why? Because both got color. If potassium manganate, you write, instead of writing potassium manganate 7, you write potassium manganate, you get no marks. No marks. Okay? Can you just add the potassium manganate and then tada, it will react? No, you need to heat it up. Okay, you heat it up together with potassium manganate 7. What is the color change? Who can remember? Who's your best friend? Come on, potassium manganate. Purple to colorless. CH3 COOH. So this is the fast way of making it. Okay, this is method number 1. Teacher, you say got 2 methods. Yeah. Who knows method number 2? Not using yeast, but using something to do with yeast. Yeast punya kawan. Not using yeast, but using bacteria. Okay? So, bacteria uses oxygen from air. This is how they make vinegar. You know what's vinegar? Yes, right. Cuka. Okay? So, there's 2 ways of making it. Using bacteria. Bacteria will use the oxygen from air and will oxidize it. So there's 2 ways of making it. It's another question that they like to ask. Nowadays, their questions are more industrial, like why use this, why use that. Okay. Can remember or not? Please, I hope this is not all like news to you. I've never heard of this before. Okay. If it is, now you know lah. Okay. Oh dear, I got no space. Okay, what is this one here? This one. Here. Ester. So ester is called esterification, right? Okay, ester uses alcohol plus carboxylic acid, and you use concentrated sulfuric acid and heat it up. Okay. I got no place to draw ester, later only we draw lah. This one, you just write concentrated sulfuric acid. Okay. So this one, I got no place to draw here, Namena. Can? Okay, so what are the things that you need to remember? The common ones is how to test. Purple to colorless. These 2 colors, every year they ask lah. Please make sure you know. Okay? And then after that, the 2 ways of making ethanol and the 2 ways of making carboxylic acid from ethanol. From ethanol to ethanoic acid got 2 ways. From to make ethanol got 2 ways. One from ethene, one from glucose. Which one is better and why? Can remember? Okay? Can I move? I can move it. Okay, this one. This one, how do they ask you? This is, okay, if you didn't get it, don't worry. Later, I will give you all time. We will take a 5-minute break. I'll give you all time to take a screenshot or a photo, okay? Just give me some time. I finish this first. Okay, this one from alkane to this is, what is this called? Substitution. Okay, substitution uses UV light, right? Okay, the question they ask you is, why do you need a UV light? Because teacher asked me memorize need UV light. Why need UV light? UV light is to provide what? Activation energy. Very good. The UV light is to provide activation energy. What kind of reaction requires UV light? What kind of reaction is this? Photochemical. Okay? You only learn 2 photochemical reactions. What is a natural photochemical reaction? Photosynthesis. This one is a synthetic one lah. Okay? Alright, so chloro. This one got no color change, nothing. You just need to remember UV light. Okay, this one we will talk about later. We're going to talk about in the next page, so I'm not going to draw it here. Okay, I'm going to give you guys a quick break. I'll put this here. This is not part of it. This one no need. Because this one is us telling you why no need to do this. Okay, I will leave it here. Like that. You all can come and take a screenshot or a photo. So wait, anything that is not clear, this one no oxygen. That's what I'm writing. No oxygen, no O2. Okay? All right, we take a 5-minute break, then we'll come back and do questions on organic chem, okay? You can come in front and take photo.
This what, man?
The engagement on SPMflix
Oh, okay. Never mind. It's okay. As long as no question mark, yeah, I will Okay, guys. I want to the screenshot. So, okay. We do a warm-up question, okay? We do a warm-up question. Can you all try and do question 1? Okay? Let's all try and do question 1. Okay, we all try and do question 1, okay? Come. Warm-up question for organic chem. We do one question, and then after that, we will do polymerization. Okay, can you all try this question? Okay, try and do question one. Question one, organic chem. We warm up from after break. Okay, try and do it, and then I'll discuss in exactly 3 minutes. Okay, just if you can't do the whole question, it's okay. It's just giving you time to read the question. Okay. Okay, 1 more minute, then we're gonna discuss. Okay, ready? Listen up. State the name given to a family of organic compounds with similar chemical properties. If you don't know how to write homologous series, we all sit down and cry, okay? You all got it correct? Yes, Okay. Explain why members of the organic compound show the similar chemical properties. Because they have the same functional group. The functional group is the part of the molecule that causes its chemical reaction. All alcohols are soluble in water because of the OH. All carboxylic acids are acidic because of the COOH. Get it? Okay. State the general formula of the organic compound here. So this is what? Ethanoic acid. So just now I wrote for you already. CNH, 2N plus 1, COOH. Okay? Now, this question might seem very easy, but it's something that you have to read carefully. So, name of A. This one got how many carbons? 1. So, 1 is meth. So, it's methanoic acid. Okay? Structural formula. Structural formula is not the one you draw. The one you draw out is displayed formula. Structural formula is you write out how it looks like. CH3, CH2, CH2, CH3 like that. So ethanoic acid looks like this. Okay, this they're asking for propanoic acid. Propanoic acid looks like this. CH3. Sorry. Wrong question. Okay, B. This one is asking you B. Okay. B. Okay. Structural formula of B. B is ethanoic acid. So ethanoic acid is CH3 COOH, right? So you're supposed to write it exactly how it looks like. CH3COOH. If it was propanolic acid, then it will be CH3CH2COOH. Can you understand? Okay. Okay. Now, molecular formula at C. Molecular formula at C. Molecular formula, okay, we all learn the CnH2n plus 1, right? So, methanoic acid would be HCOOH. Ethanoic acid would be CH3COOH. Propanoic acid will be C2H5COOH. Butanoic acid will be C3H7COOH. But this is not the molecular formula. Molecular formula is you add everything together, you add all the carbon and put it as 1, you add all the hydrogen, put it as 1, and all the oxygen, put it as 1. So it has total 3 carbon, 6 hydrogen, and 2 oxygen. That's how you're supposed to write it. Okay? Empirical formula is the simplest ratio. So of course you need to know that butanoic acid is C4H8O2. Right or not? Then only you can simplify it to a empirical formula of C2H4O. Okay, ready? Can you see the difference between the three? Yeah. Okay, so C is made by oxidation of an alcohol. Okay, so we go back to just now that one. Ethanol becomes ethanoic acid. Propanol becomes propanoic acid lah. Correct or not? Butanol becomes butanoic acid. The oxidizing agent is KMNO4. Give the chemical name. Okay, I'll come to one in a while. Potassium manganate. You don't write 7, no marks. 7. Do you need to write acidified? No. It's just the name. Okay. Name the alcohol which is oxidized to C. C is propanoic acid, right? So logic will tell you this is propanol. I have very bad news for you. If you write propanol, your answer is wrong. Why? Because ethanol, okay, wait, I'll draw for you to explain. You see, ethanol got 2 carbons, right? If you put the OH here, 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 or even here, it's all the same. Correct or not? But propanol got 3 carbons. If you put the OH here, it is propane 1 all. If you put the OH here on the second one, it's propane 2 all. Correct? When it becomes a carboxylic acid, it will look like this. CH3, CH2, COOH. Do you think this one, okay, the OH is in the middle, how can it suddenly terbang go to the last one? Possible or not? Impossible. Cannot. In order for an alcohol to change to carboxylic acid, the OH must be on the first carbon. Only if it's the first carbon, can it become COOH. Can you see? Can you see how this one is on the first carbon? Get it or not? That means this hydrogen and this hydrogen disappear to become a double bond O lah. Swap only, right? So the OH has to be on the last carbon. So therefore, if you write propanol, the answer is wrong. You have to say propane 1-ol. Okay? Can you understand? Okay, so any acid, you must write propane 1-ol. Teacher, why just now ethanol no need? Because ethanol, anywhere you put the OH, it's only one. It's still in the first carbon. Make sense? Okay? So take note of this. Got it? Got it? Okay. Now, in order for alcohol to change, it has to be acidified and it has to be in an aqueous condition. Aqueous means dissolve in water. Without water, cannot react. Okay? All right, in order for oxidation using oxidizing agent, you must have acidified potassium manganate 7 and you must have it in an aqueous solution. That means dissolved in water. Okay? All right, now, what is the type of catalyst to change into ester, acid? You don't have to write sulfuric acid, you just write acid because they're asking what type of catalyst. All right, last one. Esterification. We're going to have one whole 10-minute thing about esterification. This one definitely water lah. Let's write the easy one first. In order to write ester, it's like methyl metanoate, butyl butanoate, ethyl metanoate, like that, right? So it's two words. The first word comes from alcohol. Okay, so this one is ethanol, so it's ethyl. Okay, and then butanoic acid, so it's butanoate. But when we write the formula, we write the alcohol first. The alcohol, butanoic acid, total how many carbons? 4. But we write 3 in front because it's C3H7, COOH, total is 4. 3, 4 like that. Get it? Ethanol is C2H5OH. This is not the answer. I'm just showing you how to do. So when I want to write the organic, the formula is very easy. You just take C3H7COO, then you stop, then you C2H5. That's your answer. C3H7COO, then I stop, C2H5. So what's left over? H2O becomes my water. Get it? Okay, what does the question want you to do? Draw the displayed formula. That means you're supposed to draw this. But if you don't know how it looks like, how to draw? So C3 H7 C O O C2H5. Oh, oops. Okay. Okay. Can you see? And so what is this called? This part is called the ester link. COO. That links it together. It's called the ester link. Okay, ready? How? Can? Ready? It's okay, you guys left. You all take it all October, November. Got 2 more months. It's okay. Can do it. Okay? Can. All right. Okay. Polymerization. How many kinds of polymerization are there? 2. Addition polymerization and condensation. So let's do addition first. Okay? Now, ethene is C2H4. What you want to do is, you want to always draw it in a way where here and here is empty. Okay? Here and here is empty because all you need to do is take the double bond, open up the arms and hold another molecule. Hold each other. Okay? So, when you have polyethene, you have all these ethenes that are feeling very lonely. And so, they tell each other, I am lonely. Can we please hold hands? And then the ethene says, okay. So what happens here is, the double bond, open. Just now it's double bond, right? Now it opens up to become single bond. And they hold each other. Okay? So you started out with a double bond. You take many together. Okay, how many repeating unit is this? 1, 2. When you draw like this, it's called a repeating unit. The bonds must be open. You cannot forget and then suddenly, oh, don't draw the end. Wrong. Because you draw the end to show that it is continuing to the next guy, the next guy, the next guy, the next guy. Okay? So here is 1 repeating unit. Here is 2 repeating unit. This is called repeating unit. This is called the monomer. The monomer is the one with the double bond. Why do I need to know? Because sometimes they ask you to draw monomer, sometimes they ask you to draw polymer. Okay? Can? Alright. Can you try polypropene? Okay, try now. Try polypropene. Draw a propene and draw polypropene. Okay, draw now. Okay? Okay, now, when you draw, I know a mistake that a lot of people do is, then they draw like that. Teacher, tada, polypropene. No, this is not polypropene. Why? This is polyethylene. It's not like that. Okay, let's try again. What you need to know is, propene is 3 carbons. Okay, double bond. Okay, what you need to do is, you need to make sure this side and this side is empty. Okay? You need to make sure this side and this side is empty. So how do you empty it? You do this. You move things around. Okay. CH3, H, H, H. Now look carefully. This is not a methyl. This is just 3 carbons in a row. 1, 2, 3. Like that. Is it empty here and here? Yes. You just squash it so that the double bonds are here in the middle. The side is empty. So when they open up their bonds, it's like this. It's always like this, you know. It's always double bond, open up, double bond, open up like this. And so you put everybody up and down. CH3, H, H, H. CH3, H, H, H. Can you see? Can see? So this is propene, this is polypropene. Okay? Can you see the difference? Can or not? Okay. Try and do the same concept and do but 1 in and poly but 1 in, but 2 in and poly but 2 in. Okay? Try. Get it now. We try. Okay. You see, if you do this, if you do it this way, right, your hydrogen is still here. It doesn't have hydrogen. It starts out, you drew too many. It's C3H6 one. It doesn't have this. Every carbon must only have 4 bonds. This one got 5 already. This fellow got 5. You count and see? 1, 2, 3, 4, 5. So that's why it's wrong. It's C3H6. That's why you got it wrong. You try again. So this one you must have a bond here. You cannot just end like that.
Oh, sorry.
Here must have bond. So must have bond here. Hey, your thing must go continuous. Here and here must have bond. Here must continuous. Here. Okay? At the counter. We have coffee sweet. Go now. No need to be shy. I know you're very tired. I know you all are very tired already. Hey guys, look. The bond at the side. There. Thank you. So, this one correct. But, okay. Okay, here. We need to have bonds at the end. You cannot just stop like that. It has to continue. Okay, the bonds have to continue. Guys, pay attention. Here. This one must continue. Goes on and on and on. Okay, like this, Okay, I think some of you really don't know how to do. Come, let me show you. Build one in is one double bond here, right? Okay, look here. All the rest are hydrogen, okay? I want to move. Okay, is build one in C4H8? Yes. So, this is my double bond. So here and here, I want it empty. Right or not? Can see, okay, C first. Is this C4H8? Yeah. Here's my double bond, right? So here and here, I want it empty. Okay, so what is this? This is hydrogen. I can just move it down like that. Still the same? Yes, What is this here? C2H5. So I just move the C2H5. You can either move the C2H5 up or down. Doesn't matter. Okay, now I want you to count. Is it still C4H8? Yes. Here and here is empty. Can see or not? So when it becomes polymerization, it's just H, C2H5. Can go on and on. Can see it's just break the bond only. Okay, if you're feeling lost, go back and look at all the old videos. We have lesson videos on alkanes also. And we also lesson videos on polymerization. Go and look again. Go and relearn again. Okay? Still got time, Okay. Can? Now, build 2 in will be like this. CH3, CH3. Because if you put it down, it will be 1, 2, 3, 4. 4 carbons in a row. Do you understand? If I put this down, it will be like this. Build 2 in. So I'm just moving this thing and this thing down and or up so that my sides are empty. Can see or not? Okay. Okay, got it. Okay, yay. This one only addition. Belum masuk condensation. We're going to do condensation soon, okay? Okay. Do you all need a brain reset for a while? 5 minutes? Brain rest? Okay. Okay, everyone take a deep breath. I know, teacher, I really don't like this one. Carbon. I know, but I can't do anything. Okay. All right. Okay, kiddos, can? Okay, now, you don't understand, you go back and watch the video. You also go log in on IGCSEflix. There's also lesson videos on this. Okay, you might need a whole lesson video, yeah? Can, but no place. Can. Usually there's no place to draw. That's why. Okay. This one, right? Change here, change there, change here, change there, right? There's one more. Alkane can change to alkene. Who can tell me, this one, okay, let's do something we can do. Okay. Let's do something we can do. So easy question, okay? This is, easy question. Alkanes and alkenes. Just now we just did, the alkene change to alkane is add hydrogen, 200 degrees Celsius and nickel, right or not? Okay? If the alkane want to change to alkene, what's the process? Cracking. Very good. Change it back is cracking. So usually cracking, we take long hydrocarbon chains and crack it. Okay? Can? If you can remember the word cracking, very good lah. Okay? Alright? If you can remember catalytic cracking, even better. But I will give you marks for cracking. Cracking uses heat and catalyst. It's taking the long hydrocarbon chain, break into smaller, okay? Smaller alkenes. Okay? Decane has 3 carbons. 10 carbons. It forms ethane and ethene as the only product. Okay. Decane, so remember alkane. How I know it's alkane? Because it's decane. A-N-E. So CnH2n plus 2. So it would be C10H22. Okay. It forms ethene and ethane. Okay, it forms ethene and ethane. So you just need to balance the equation 4. 4 times 2 is 8. 8 plus 2 is 10. Okay. All right. Try and do B and C. B and C you definitely know how to do because I literally just taught you. Okay? Okay. Ethane reacts with chlorine at room temperature. Okay, ethane reacts with chlorine at room temperature. Okay, to form chloroethane. Isn't this the same as just now? Same, right? Okay, and one other product. Name the other product. Oh, okay. This one, teacher, I don't like this question. Okay, now we draw it out. So this one is ethane, right? React with chlorine. Chlorine is ClCl. Okay, so how do they switch? They switch, they switch this and this. Switch around, right? So here become Cl, here become H. They switch it around, right? So now this one is chloroethane. What is this? HCl is what? You cannot write hydrochloric acid because hydrochloric acid is only hydrochloric acid when it dissolves in water to form aqueous. This is called hydrogen chloride. State the condition. So everybody knows. What is it? UV light. Okay, this one is substitution. This one is what? Addition. How I know it's addition? Because only one product. Okay, can? Okay, we're going to do, okay, we only have 1 hour left. I want to do polymerization. Polymerization, the what? Condensation polymerization. Can you all turn to page 11? 11, okay? Actually, organic chemistry, 3 hours is not enough. Because it's so much, right? Page 11, okay? How many kinds of condensation polymerization are there? 2. Okay, we talk about the synthetic ones first. One is, okay, look at page 11. One is polyester. The other one is polyamide. Whether it's polyester or polyamide, the first, okay, so what they do is, I want you to imagine, okay, polyamide. If you have younger brothers and sisters, or nephews or nieces or whoever, or you remember from your childhood, there's a game. One of the toys that you play for, IQ toys, it's called connectors, okay? So a child will be given a thing which has hooks on one side and rings on the other side, okay? So they will be given toys like this . So if the child wants to do this, how are they going to join it together? Child go and join ring with ring . Cannot join, right? Cannot. So what must the child do? Hook and ring, like that. Hook and ring like this, okay? So that's basically what we are doing here. This is the hook, this is the ring. This one can join in, okay? The hook can join with the ring can join with the hook. Correct or not? And if I want to make a long train, what do I put? Hook, ring, hook, ring, hook, ring. Correct? Okay. The same concept is for this. Okay, it's exactly the same concept. You imagine this is the hook and this is the ring. Okay? In order for them to join together, you must have molecule A, molecule B, molecule A, molecule B, like that. Okay, how do they hook together? They hook together because, okay, I will put this here. OH, OH. Having one alcohol is called alcohol. Having one OH is called alcohol. Having two OH is called a diol. Having one COOH is called a carboxylic acid. Having two COOH is called a dicarboxylic acid. So a dicarboxylic acid. Okay? So what happens here is the OH. OH and COOH. Okay, I want you to think. OH and COOH. Who has more things to give away? COOH. It's like, I got 100 ringgit, you got 10 ringgit. I give more money, like that. Okay, so COOH has more money. So they will give OH. But, see, the one that is alcohol, OH got not so much money, so they will just give the H. Okay? When the OH and the H join together, what do you make? Water. So making water is called condensation. So this part, H, and this part, OH goes away. So directly join like this. Get it? So on the other end, you must get rid of the H. It will join like this. And then here you must get rid of what? The OH. And join directly with the bond. Can? So what am I removing? Water. Okay, so let's try and draw. Okay, teacher, you say here O. Okay, don't draw the H here. Where did my H go? H went to the next one. Okay, so here is supposed to be what? COOH, right? It's supposed to be COOH. What happens is, I'm very generous. I give away my OH. Understand? So the OH and the H join together. Here, CO join to my O here. CO join to your O here. Can you see that? All right. COO is found in ester. So it's called an ester link. So this part, if they ever ask you, this part is the ester link. Sometimes they ask you to circle. Okay. I want you to tell me, where is the repeating unit? Do you remember this word repeating unit? From here all the way to here is one repeating unit. One repeating unit. Can see? Okay. Today like extra cold like that. I think because today is the last day, so extra cold. All right. The type of polymerization, condensation. Okay. Name a polyester. Okay, this one only need to memorize one, PET. Don't make your life difficult, just remember one. Okay? Do you understand? Okay. Oh, teacher, I hate this. All I can see is O and O and C and rings and... Okay. Let's go back to this. Let's go back to this. Okay. So now, if these two join together, it forms polyester. If I have this, but instead of this with alcohol, with the diol, I do it with somebody else. Amine. Okay. If this one plus this one together, then it is polyamide. What happens is the same thing. OH and H get together, become water. Okay? The only difference is the bond will look like this. C, O, and H. Get it? Same concept. Instead of COO, it is CONH. This is called an amide link. Okay? So if many ester, polyester, many amide, polyamide. Okay? There are two kinds of polyamide, natural and synthetic. Let's do the synthetic question first. Look at page 12. Look at page 12. Do question 5 using the concept I just taught you. Okay? Page 5. Page 5. Do question 12. Page 12, question 5. Okay? Page 12, question 5. Okay, nah? This one. This question. Okay. Can do that. Okay, so here is one repeating unit. Here to here, one repeating unit. Here to here is two repeating units. Okay? Can you see how it is CO, CO, and then here is NH, NH. Okay? Can see how it looks like? So the two types just now is dicarboxylic acid. If it's with an ester, it's with a diol. But now it's with a amine, diamine. The NH, this one, right? NH is amine. Amino lah, amino acid, amine group. So if it has two, it's diamine. Okay, can? Can? Alright, so what's the difference between this one and this one? This one is synthetic. This one is synthetic. Okay, we finish this, then we're going to go do, what you call it? Paper 6, okay? This is natural. So natural is made from amino acids. Okay? Natural is made from amino acid. Many amino acids join together become protein. Okay? This one, right? Synthetic is this molecule. This molecule, the first monomer, has NH on both sides. See here, like that. NH on both sides. And then the other monomer is dicarboxylic acid, COH on both sides. For natural is, so go back to the concept of just now I told you, hook and ring, right? Synthetic is like this, hook, ring, like that. Natural is hook, ring, like that. Hook and ring. Can you understand? This side is COOH. This side is NH, like that. Okay? It has both functional group in one. So, COOH, NH2. This is how amino acid looks like. Can you understand? Okay, so this one is natural. So how does one amide link look like? This one is the amide link. Okay? Yeah? R means, this R means, because there are many amino acids, right? 20 over amino acids. It could be CH2, it could be H, it could be CH3, it could be C2H5, it can be different things. So, when it's a different thing, it becomes a different amino acid. So, it can be H, or CH3, or C2H5. It could be a variety of things. So, whenever I change this part, it becomes a different amino acid. Get it? Okay. All right, when you're done, we're going to do paper 6 now, okay? Because now I have no time. Okay. If we have time, we come back to this. Okay. Look at page 26. 26. Okay. Okay, when you're done with this, you look at page 26. Okay. Ready? Okay. What are the common errors? Oh, guys, this one, right? Go home and make a list of everything. I made a list of a few already. Okay? Haber, contact, hydration, hydrogenation. That's actually almost all. Is there any more? Not that I can remember. Okay? Can you remember? Okay, I made a list here. Catalyst, temperature, pressure. Okay? Catalyst, temperature, pressure. All right. Please turn to, there. Here it is. All right. Paper 6. All of you doing paper 6? Anybody doing paper 5? No, I don't think so, right? Anyone doing paper 5? No, Okay. So, paper 6, Okay, so paper 6, what are the common errors? Okay. They will say the experiment is about, must maintain the same temperature. So then they ask you, why does the temperature go down? Because heat is lost to the surroundings. So how can you maintain? Use a lid lah. Duh. You can use a lid, or what else can you do? Thermostatically control water bath. Or you can just say water bath. Okay, but the easiest one is thermostatically control water bath. Okay, now, when you want to measure, you measure at eye level. Okay, this is common lah. This is a common mistake. Okay. They will always ask you error. We always see the word error, right? Okay. What's an error in an experiment? The error in experiment is always, they say they use measuring cylinder. Cannot use measuring cylinder. Should use burette or pipette. Because why burette or pipette is more accurate? If the question already uses burette, you cannot change it to pipette. Burette and pipette is equal accuracy. Okay? So one other thing to do is stir. Okay, all the variables has to be, all the other variables constant. I'm going to talk about it. Okay, so use the same mass, volume, concentration. Check the apparatus. Allow crystals to dry before weighing. So, if they want to ask you how much water or has all the reaction occurs, you need to weigh, cool, heat again. Okay, cool it, weigh it, and then reheat to ensure all the water is lost. Okay? Okay, start the stopwatch as soon as reaction begins and rinse apparatus with the solution to avoid the dilution. Okay, so these are common errors that they will ask you. Okay, whenever they ask you a question, okay, let's start with something easier first. Okay, we do something easier, this one. Wait. This one. Okay, this is the last, this is the Mei Jun paper. Page 28. Okay, read the question. Question 4. Okay. Every time you want to do an experiment, make sure you know how it looks like. If you don't know how it looks like, you cannot do it. Okay, so if you don't know how it looks like, should you not do it and choose a different question? Where got different question, you think? Okay, SPM can choose question A, question B. Okay, this one don't have, you have to choose all. All right, so tin is a metal that is between copper and iron. Okay, the ore cassiterite contains the compound tin 4 oxide. It is insoluble water, reacts with dilute acid and forms aqueous solution of salt. The ores are cassiterite contain no other compound and are insoluble water with no other compound. This reacts to form aqueous solution. Okay, this describe how you could obtain a sample of tin metal, starting with large lumps. Okay, highlight the word large lumps. Okay, now, they have asked this many times, okay? Sometimes they ask copper. Sometimes they ask other stuff like random stuff, but it's always the same thing. Okay, now if something is a large lump, what must you do first? Crush it. Okay? This one is not an experiment where you need variables. Not all experiment got variable. You crush it with what and what? Pestle and mortar. This is a mortar. This is a pestle. Correct now? Okay, so first you crush. You say the word crush with pestle and mortar, you get 2 marks already, you know. So, it's good to not forget to look at the word large lumps. Okay? You just say crush to smaller pieces or crush it with pestle and mortar, you get 2 marks already. Okay? Pestle and mortar. Okay, now you got tin oxide. You want to get tin. Okay? It is between copper and iron. That means it's more reactive or less reactive than carbon. Hui. Okay. The question says tin is between copper and iron. So that means it's here lah. Okay. So carbon is here. More or less reactive? Less. So literally all you need to do is crush, 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 mortar and pestle, crush, 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 become powder, and then you put it in a crucible, the crushed powder. All you need to put is add carbon. Where do you get carbon from? Carbon powder lah. Everywhere also got. All you need to do is add carbon powder in a crucible. Do you know what's crucible? That small thing that look like a teacup. And then all you need to do is heat. That's it. Okay? What kind of reaction is this? This displacement. So carbon displaces tin from tin 4 oxide. 6 marks already. Using a mortar and pestle, crush it, crush the cassiterite into smaller pieces or powder or whatever, put in a crucible together with carbon powder, heat. This is a displacement reaction. Ta-da! Not even 6 sentences. Do you understand? Yeah? Can lah, but yeah, usually people use carbon. Can. So there are actually 4 methods to do it. You can use this. You can add acid and then put iron or zinc or whatever. You can add acid and then do electrolysis. Same. After you add acid, it's a solution. Can you do displacement? Can. Okay, but I find this is the easiest. No need to talk so much. Just use carbon lah. As long as it's less reactive than carbon, just use carbon. You want to use a more reactive metal? Can. Can use zinc, can use iron, can. But just use carbon. Easier for you. Yeah? No need. You only add acid. It's insoluble in water. If you want to do an aqueous solution, then you add acid. That means the tin oxide, after you make into powder, you add, let's say, hydrochloric acid lah. Okay? Then it becomes aqueous solution, tin chloride, aqueous. Then you add zinc. Then displaces it. This one very troublesome. So many steps. Yeah, everything is solid. You just heat it up. This is the one that you just heat in a crucible. You know blast furnace? You know blast furnace, how iron oxide can actually react with carbon to form iron and carbon dioxide? That one? Same thing. In the blast furnace, it's all solid, right? Right or not? Okay? So, this, if you don't want to do solid, you can use aqueous solution, everything. But I feel it's why you want to make your life difficult. Okay? This one, you just use solid. Take powder, take the solid, crush, make powder, put in crucible, put carbon, heat, ta-da! Reaction happened already. Okay? The tin, haven't you all done this before? The carbon more reactive, it will steal the oxygen, say, it's mine, and I get tin. Like that. It literally says no other compound. Soluble in water, yeah. And no other that react acid. This is actually telling you that you can use acid if you want, but you don't have to. You don't have to. Okay, the other compounds are probably sand. The sand is not going to react. Okay. But you don't have to. Okay, they are telling you this so that if you don't know how to do this one, you can use the acid method where you add acid, but you don't have to. You still get 6 marks here. You want to add acid also can. That means this one, you let's say you get an aqueous solution, then you do displacement. It's extra 2 steps. Okay? Okay? Oh, you're confused because they write here. Yeah, it's insoluble with water but reacts with acid to form aqueous solution. There are no other. So actually, if you use this sentence, and this sentence, you can answer the question already. You don't need the middle sentence. But they're just telling you in case you want to use acid. Get it? Can? Okay. Okay. We do something with variables, okay? Okay, question 1 is with variables. Okay, read question 1. Let's do question 1. Okay. Liquid alcohols can be burned as fuels in spirit burners. The energy given out can be used to heat water in a boiling tube. Describe how an investigation can prove which of these 3 liquids, ethanol, propanol, butanol, butanol, heats the water tube the fastest. Okay? So, there's few ways you can do it. Okay? Few ways you can do it. So, obviously, your water must be the same volume. Okay? Use logical things. So, you don't have to write the words, my constant variables are. No need, no need. You just say, prepare 5 centimeter cube of water in a boiling tube. Okay? And then, use a thermometer to measure the initial temperature. Alright? And then what do? You can explain how you got 5 centimeter cube. How did you measure 5 centimeter cube? Using a measuring cylinder. Don't have to use a pipette. You can write pipette also. Doesn't matter. Okay? Because, why? Because this one is not titration, so it doesn't have to be so accurate. Okay? So you can say measuring cylinder, measure 5 centimeter cube. Okay? And then you put a thermometer and then write down the initial. Okay, so you can do a few things. You put the ethanol. You can measure time taken to reach something logical 50 degrees Celsius. Okay, let's say measure the time taken to reach 50 degrees Celsius. And then repeat using the same volume of water, same initial temperature for propanol, butanol. The one that uses the shortest time is the best view. Okay? You don't have to copy if you can't remember, don't worry. The year is here and the marking scheme is online. Okay, so everything is online. You don't have to worry about that. Okay? Now, another thing I can do is actually, I can just put inside the spirit burner, I put 2 grams or 5 grams. And I heat until no more. So I measure how high the temperature goes. Can also. Okay? As long as it's logic. So, 5 centimeter cube of water in a boiling tube. You measure the 5 centimeter cube using a measuring cylinder. the temperature should be at, you say lah something. Okay? You say something logical lah. Okay, start with 25 degrees Celsius. Do something logical lah. Okay? Alright, use a thermometer to measure the initial temperature. Heat it up using ethanol. Measure the time taken for it to become 50 degrees Celsius. Repeat the same experiment. Okay? Repeat the same experiment with the same volume of water for propanol and butanol. The one that is the fastest is the best fuel. Can? Okay? That's it. Don't need to be so complicated. You just have to remember, there are not that many experiments there. There's this kind of experiment, preparing the salt, and then what else? Rate of reaction, okay? Extraction, what else? Electroplating, okay? So there are not that many experiments for you to go and search the whole world for, okay? Can you understand? Is it simple? Simple, huh? All right. Okay, questions? Okay, can we try one more? Okay. This is a little bit, not very hard. It's just a little bit higher order thinking skill because so many things to read. Okay, can you try this? Try this, try this. Question 2. Let's try this. This one is calculating the percentage in a sample. How much percent is in a sample? Okay. Okay, it's a trick question a bit lah. Which acid should you use? Nitric acid, you dissolve everything because the aluminium does not react with nitric acid. Did you why they put hydrochloric acid? For you to think a bit lah. Okay, so basically, duralumin is a kind of alloy. It has aluminium, copper, magnesium, manganese. I want to see inside my sample of duralumin, how many percent is aluminium? Okay, in order for me to calculate, do I need to know the mass of the duralumin? Yes. So why don't I take a 5-gram sample of duralumin? First, I take a 5-gram sample and then I add, what should I add to the sample? Nitric acid. Okay, who will react? Will the copper react? Yes, but it will only react when it's heated. So I need to heat. Okay, so far I already got three marks already. Prepare a 5-gram or weigh a 5-gram sample of duralumin. Okay, weigh a 5-gram sample of duralumin. Add nitric acid and heat. Where should I add it? Where should I add nitric acid? In a beaker. Logic, right? In a beaker. add the duralumin and acid, and I heat. Okay? Will my magnesium react? Yes. Will the manganese react? Yes. Will the copper react? Yes. Okay? So, once everybody reacts, okay, once everybody reacts, what should be left only? Only the aluminium. Okay. Now, do I have to make sure all the copper, all the magnesium, all the manganese reacted? Yes. So, should I add more duralumin or more acid? More acid. Adding more is called what? Excess. So, all you need to say is add excess. Okay. Weigh a 5-gram sample of duralumin, 1 mark. In a beaker, add nitric acid in excess. There's another mark. Add nitric acid in excess. Okay. Heat it up. Alright, heat it up together. And then, after you heat, react. What's left inside? Only aluminium. Do I use my hand to take out the aluminium? No, what do I do? Filter. And after I filter, is it dirty or clean? Is my aluminium dirty or clean? Dirty, because it's full of acid. So I need to rinse, dry, and then weigh. That's it. Okay? Do you need to show how to count? Yes. Okay, so do you understand the experiment? 5-gram sample of duralumin, yeah? Excess. You just write excess. Excess means more than required to react. So you just add more, you just add a lot of acid and a little bit of duralumin. Oh, because I want to react all the copper. If I don't add enough, I don't add more nitric acid, there will still be copper left over, there will be still magnesium left over, there will still be manganese left over. I must make sure all of those three are gone. So that's why I add extra acid. Make sense? Okay, so let's start again. 5-gram sample of duralumin in a beaker. Add acid in excess. 3 marks ready. Heat it up. 4 marks. Filter. 5 marks. Wash and dry the aluminium, and then how to count. Okay, so your percentage of aluminium is the 5 grams, and then the mass of aluminium over the 5 grams times 100. That's it. Okay, you originally had 5 grams. You calculate the final aluminium, how much, and then you times 100. Okay? Okay, guys, later before you go, you need to take a photo, fill in feedback form, okay? And then outside there's some more notes from other subjects, so you want to take for your friends also can. Okay? Okay, I think we have time for one more question. Okay? Okay, are you all ready? Can? So, writing the 5-6 mark question, right, doesn't have to go on and on and on and on. This one is all 6 marks. You don't have to write so much. Okay, you just have to write the correct experiment. Okay, can? Ready, yeah? Okay, we're almost done. Okay. Think, question 5. Okay, how to do this? So obviously, you need to use a measuring cylinder to prepare how much water? 100 centimeter cube lah. You need to know how much magnesium sulfate dissolved in 50 at 50 degrees Celsius. Okay, so what do? Add lah, add until it dissolves. Correct or not? Okay, let me teach you the easiest way. Okay, you add 1 gram at a time or 2 grams at a time. Okay, so using a measuring cylinder, prepare 100 centimeter cube of water, heat it up to 50 degrees Celsius. Okay, all right. How do you maintain this temperature? Thermostatically control water bath, or you can just say water bath. Okay, and then there's a few ways you can add. You can do one way, which I don't like because a lot of words to write, is you take magnesium sulfate, okay, you add a lot. You add like 100 grams, a lot. You add, and then you stir, and then you filter out the one that doesn't dissolve. So troublesome, right? The easier, because you don't have to actually do the experiment, right? All you say is, you add 1 gram at a time until it no longer dissolves. So simple, correct not? Okay? Teacher, who's so free to add 1 gram at a time? Do you actually have to do it? So just write lah. Doesn't matter what. No one is gonna, the Cambridge is not gonna call you and ask you to do the experiment, okay? So, prepare 100 centimeter cube, measure using measuring cylinder, heat up the water to 50 centimeter cube, maintain using a water bath, okay? Using a spatula, add 1 gram of magnesium sulfate at a time until no longer dissolves. Okay, you add 1 gram at a time until it no longer dissolves. Okay, so solubility is the mass over 100 centimeter cube. That's it. You don't even have to talk about it. That is the mass over 100 centimeter cube. Teacher, what a simple experiment. Yeah. Okay, not all experiments are hard. Okay, can you understand? Easy or not? Easier. Make sense or not? Any questions? Okay. Can? Okay, I want to go back and do one question. I really wanted to do it just now. Okay. Can you all, since we were doing organic chemistry, can you all turn to just now that question? Wait, let me find it. Okay, page 13. Okay, page 13. I really wanted to go through this. Okay, page 13, 1, 3. We try and finish it, okay? Page 13, 1, 3. The one about organic chemistry, since we were doing so much organic chemistry today. This one, okay? I'm sure you can do 1, 2, 3. Okay? I'm sure 100% you can do 1, 2, 3. G, 1, 2, 3. H is a little bit higher order thinking skills. Okay? Question 6. Okay. I'm sure you have done G1, 2, 3 because it's so easy. All right. So, why is this an addition reaction? Only one product form. What's the color change? Orange to colorless. Easy, right? What is, okay, now here's the thing. Okay, maybe you are very, very good. You see from far you can do only. Maybe you're like teacher. I see, I cannot, I have to draw it out. So, CH3, CH, Br, CH, Br, CH3. Oh, now I know how it looks like. So, oh my goodness, what did I do? Okay, so then, looking at this, you can see that the Br is on the second and third carbon. Okay? All right, so it's 2, 3 dibromo butane. Remember, it's A and E. Get it? Okay? So, CH3 is this CH3. CHBr, CHBr, and then CHBr, CHBr, and then CH3, CH3. Get it? Can see or not? Okay. Okay. Under certain conditions, okay, this one is a high order thinking skill. 1 mole of B. What is B? Butene. Butene got how many carbons? 4 carbons. Reacts with oxygen to form 2 moles of carboxylic acid D. That means they split to form acid with 2 carbon lah. Because for 4 carbons, you divide 2 is 2 carbons each, what? So each of your carboxylic acid has how many carbon? 2. So who are they talking about? Ethanoic acid lah. Understand or not? So you're just supposed to draw ethanoic acid. C, O, O, okay, this one, O dash H, okay? Okay, so it reacts with oxygen to form CH3COOH, okay? But you need to have 2 of it, and so you need to have 2 oxygen. All right. Okay, 2 things. Please study. Please watch all the videos you can. Please go through your past year papers. Please go through your syllabus content. Okay, there is still time. If you are an October, November student, there is still time. Okay, there is still time for you to study. You just have to actually go and study. All right? Any last minute questions before I end? Anything? Okay, so please go back and finish the paper if you can. Okay, the marking scheme we will post later. Actually, no need marking scheme, all the answers are there, all the years are there. All right, can? But try and do, really try and do, and then you will realize, hey teacher, all the questions are always repetitive. Okay, all right, tear out your last page and then do your thing. All right, guys. Okay, all the best, yeah. Okay, fill in your form, then we'll come and take a photo. Welcome.
Thank you, everyone. Me and my friend just met all the questions. So you can pass to Kak Lina behind there. Anak.
Tak apa. Dia dah TikTok dia dah stop dah.